Welcome to the DIY Honda Garage channel. The DTC C1840-12 indicates that there is a high voltage detected in the differential fluid pressure sensor circuit, specifically in the context of the real-time all-wheel drive AWD system. This can point to issues in either the electrical circuit or hydraulic circuits associated with the real-time AWD. The differential fluid pressure sensor itself is critical for monitoring the fluid pressure in the rear differential. It is usually located near the rear differential assembly, connected via a 3-pin 3P connector. If there's a malfunction, it may adversely affect the AWD system's operation, leading to performance issues and potential drivability concerns. Before delving into the troubleshooting process, it is crucial to understand how the AWD system operates and its importance in distributing power effectively to enhance traction on varying road conditions. The DTC C1840-12 revolves around the differential fluid pressure sensor, an important component in the rear differential's operation. This sensor sends fluid pressure information to the real-time AWD control unit, allowing the system to adjust power distribution as necessary. It is located near the rear differential assembly and uses a 3-pin connector for its electrical links. A high voltage reading implies that the control unit is not receiving the expected voltage signals, which could affect the system's overall performance and lead to a loss of traction. Understanding the sensor's function is critical, as it plays a direct role in maintaining the vehicle's stability during various driving conditions. A malfunction can result in the DTC being activated and may necessitate further diagnostic testing. There are several possible causes for the DTC C1840-12. One of the primary culprits could be an electrical circuit problem, which often arises due to damaged wiring, poor connections, or malfunctioning components. Additionally, there may be a hydraulic circuit issue that can affect the fluid pressure readings. Another significant cause is a short to power in the PS1, power supply 1 line, which could lead to excessive voltage being sensed by the differential fluid pressure sensor. Finally, there could also be an open circuit in the PS1 line, preventing the correct voltage signal from being transmitted to the real-time AWD control unit. Each of these scenarios can lead to high voltage conditions being reported, triggering the DTC. The symptoms related to the DTC C1840-12 can manifest in various ways. Drivers may notice performance issues associated with the all-wheel drive system, as the vehicle might struggle to maintain traction under certain driving conditions. Additionally, a warning light may illuminate on the dashboard, alerting the driver that a problem has been detected within the system. The vehicle could also experience a loss of traction control, which could compromise safety when navigating slippery or uneven road surfaces. Each of these symptoms is indicative of underlying issues stemming from the differential fluid pressure sensor or associated wiring. Early recognition of these symptoms can help to mitigate more severe consequences and ensure the AWD system functions optimally. The first troubleshooting step requires starting the engine and checking the parameters using the Honda Diagnostic System, HDS. It's essential to review specific metrics such as the voltage of the oil pressure sensor for the rear differential. The detected voltage should exceed 4.14 V for normal operation. If the readings align with this threshold, it confirms that the current conditions are as expected, and the technician should proceed to step 3. However, if the voltage reading falls short of the specified threshold, the technician should follow the indicated procedures in step 2 for further diagnosis. This first step is crucial in isolating the root cause of the high voltage condition in the differential fluid pressure sensor circuit. In this troubleshooting step, the technician should clear the DTC using the Honda Diagnostic System, HDS, before executing a functional test in the real-time AWD menu. This function is critical for assessing the oil pressure control operations. Following that, the technician should specifically conduct the oil pressure control test through HDS. If the test results return to normal, it indicates that the system may have experienced intermittent failure, meaning that no further action is necessary at this time. Conversely, if the test does not yield satisfactory results, it confirms the recurrence of the issue. At this point, specific instructions from the HDS linked to the test results should be followed diligently for more precise diagnostics and potential repairs. In this step, the technician will focus on assessing potential failure areas, starting by turning the ignition switch to the lock position. After this, the next action is to disconnect the rear differential fluid pressure sensor's 3P connector. With this connector removed, the ignition switch should be turned on to the on position. At this juncture, the technician will measure the voltage between test points designated as PS1 and SG, using the corresponding terminal numbers on the rear differential fluid pressure sensor's connector. During this check, it is paramount that the voltage reading is around 4.14 volts or higher to confirm proper operation. If this value is met, the technician can confidently proceed to step 4. However, if the reading is lower, it suggests a deeper issue requiring scrutiny. After confirming that the voltage reading in the previous step was appropriate, this step involves checking for short circuits in the PS1 line. The ignition switch should again be turned to the lock 0 position before disconnecting the real-time AWD control unit's 24P connector. Following this, the ignition should be turned to the on 2 position once more, enabling the technician to measure the voltage between the second test point and body ground. The readings should ideally show around 0.5 volts or higher. This step is pivotal to identifying any short circuits that may exist in the PS1 wire, connecting the rear differential fluid pressure sensor and the real-time AWD control unit. If a short is identified, the technician should embark on necessary repair actions to rectify this fault. In this step, the technician will assess for an open circuit in the PS1 line. To initiate this, the ignition switch should be turned to lock 0, and a jumper wire must be used to connect the designated terminals. Specifically, this means wiring terminal A from the rear differential fluid pressure sensor's connector to the body ground. Once the jumper wire is in place, the ignition switch is turned to on 2, allowing the technician to check the voltage again with the HDS. The voltage of the oil pressure sensor for the rear differential should drop below 0.1 volts for the system to potentially be operating correctly. If so, this reinforces the suspicion of an open circuit in the PS1 line, as expected. Should these conditions be met, the technician is guided to the next step of checking for continuity. This troubleshooting step emphasizes ensuring continuity in the PS1 wire. Begin by switching the ignition to lock 0. The jumper wire should be removed, and the technician will disconnect the real-time AWD control unit's 24P connector. With the connectors safely detached, checking continuity between the designated test points will be the next focus, as it is crucial to confirm that electrical signals can flow properly along the PS1 line. If continuity is found present, the next course of action could be to update the real-time AWD control unit with any outstanding software patches, or possibly substitute it with a known good unit for verification. Once confirmed to work with the updates, troubleshooting could be considered complete. However, if continuity fails, this indicates a more concerning issue that may require repair of the open circuit found. In this step, a further examination of the rear differential fluid pressure sensor is warranted. After turning the ignition to the lock position, the technician should set up a jumper wire connecting two terminals on the rear differential fluid pressure sensor. This action is critical, as it allows for testing the sensor's functionality more directly. After establishing this jumper connection, the ignition should be turned back to the on second position. Subsequently, checking the parameters via the HDS is essential to observe the voltage of the oil pressure sensor. If it reads below 0.1 volts, this indicates a potential failure of the rear differential fluid pressure sensor. Hence, a recommendation to replace it would follow. If the sensor operates correctly, the troubleshooting process would continue towards resolving other issues found during previous checks. The concluding step in the troubleshooting process examines the SG line for continuity. Begin by switching the ignition to the lock position to ensure safety before proceeding. Following this, the technician will disconnect the real-time AWD control unit's connector, preparing the system for the continuity check between designated test points. Establishing this continuity is crucial because a break in the SG wire can cause symptoms that mimic the initial complaint. If continuity is confirmed, possible upgrades or replacements for the real-time AWD control unit should be considered. Alternatively, if the continuity fails, it necessitates repairs to the SG wire, linking the rear differential fluid pressure sensor and the real-time AWD control unit. This final check ensures all potential wiring issues are addressed effectively. After completing the necessary repairs and replacements, it's imperative to conduct a final verification of the system's integrity. This involves carefully test driving the vehicle under conditions that resemble typical driving scenarios. The technician should monitor the vehicle's behavior, watching specifically for any reoccurrence of the DTC C1840-12 or related AWD performance issues. Additionally, ensuring that the all-wheel drive system functions as expected during various maneuvers is critical. If everything checks out and no warnings are displayed, this confirms that previous repairs were successful. It is essential for the technician to document all findings and confirm with the vehicle owner that the system is now operating correctly. Preventive maintenance plays a vital role in ensuring the reliability of the differential fluid pressure sensor and the associated AWD system. Regular inspection of sensor connections is crucial, as corrosion or looseness can lead to intermittent failures. Technicians should also perform routine checks on the wiring to ensure there are no signs of wear, fraying, or damage that could lead to circuit failures down the line. Furthermore, maintaining appropriate fluid levels and quality within the rear differential can also prevent malfunctions and keep the system running smoothly. Implementing these preventive measures can help avoid future issues and ensure the longevity of the vehicle's AWD system, providing optimal performance across driving conditions. In summary, understanding the function and location of the differential fluid pressure sensor is crucial for effective troubleshooting of the DTC C1840-12. Following the detailed diagnostic steps methodically allows for accurate identification of the root causes behind the high voltage condition in the sensor circuit. Each step clarifies the process of investigating electrical or hydraulic issues effectively. Additionally, implementing preventive maintenance strategies significantly reduces the likelihood of encountering similar faults in the future, ensuring that the real-time AWD system remains efficient. Overall, thorough knowledge and meticulous attention to detail in both troubleshooting and maintenance are key for ensuring optimal vehicle performance. Please like and subscribe to the channel. See you next time.